And we'll move to the next submission, which is an oral presentation by the first 6 years, as outlined in CMD 15H 5.8 and H 5.A. And I understand that Mr. Castrilli will make the presentation. Over to you, sir.
Thank you, Mr. President and members of the Commission. My name is Joe Castrilli. I am a lawyer with the Canadian Environmental Law Association in Toronto. To my left is Dr. Ian Fairley, a consultant, an expert from the United Kingdom, who will speak to the health effects or health risks of tritium emissions from the SRB facility. At the desk behind me is Dr. Hendrickson, who has joined us again because he prepared a report on SRB emission levels. And we appear on behalf of First 6 Years, a group that's based here in Pembroke. There's a final person who's with us, or who will be with us in a moment, Ms. Kelly O'Grady, who's the president of First 6 Years, who is also with us for this particular presentation in case there are any questions that are asked that are better answered by her. We've prepared written submissions that are before you. In my case, I do not propose to speak to mine any further than what is already in the written material, subject to any questions the Commission might have of me. So at this point, I'm going to turn the microphone over to Dr. Fairley.
Mr. President and Commission members, thank you very much for this opportunity to speak to you this afternoon. I'm going to be speaking about tritium. It's been a subject of my studies for at least 35, maybe 40 years. It's a fascinating radionuclide, and unfortunately it's also very hazardous and also very misunderstood. Let's go have a few introductory comments about how much tritium there is here at SRBT. These are emissions from 2008 to 2014, but before that there were much larger emissions, which in fact resulted in SRB's license being revoked for a few years. These levels are very high in comparison with say, Darlington, or with Dungeness in the UK, and all German nuclear power stations. It gives you a range there of the number of terabecquerels per annum. And you can see that SRB is relatively high, even although it's not a nuclear power station. When the plant is in operation, and we've talked about air emissions in various models or so, this is the result of an IAEA modeling exercise showing tritium exposures from inhalation here 1 terabecquerel was emitted over a 1 hour period. And you can see that the exposures come out from this power station, happens to be Cernavodă in Romania, and the winds were coming from the southeast to the northwest, and you can see a plume. And this is what happens, of course, here at Pembroke. This is looking at organically bound tritium doses from cow's milk and showing, again, a 1 terabec emission where the wind is light and variable, and you can see the doses are much higher. If we look at tritium concentrations in air near Canadian reactors, and this is the reason why I'm putting this up is to show you the pattern of tritium concentrations near a variety of nuclear generating stations here in Canada. The y-axis is logarithmic, and the values range from 0.01 to about 30. In other words, a range of 3,000, which is very, very high indeed. Just for a matter of information, the only figure that I could see for the tritium concentration here at Pembroke was 12 becquerels, and this fits in, if you look to the extreme left, the sort of mauve blobs. That's from Pickering, and you can see that it fits within what's happening, what has happened, or what has been measured at Pickering. Also a very large tritium emitter. However, we're really concerned to find out how much tritium gets into foodstuffs. And this graphic, by the way, the previous graph and this one were in fact prepared for CNSC about 12 years ago by Dr. Osborne and his colleagues. And I have permission from him to use these graphs. And you can see here that the closer you get to the source of the emissions, that the tritium concentrations in food rise exponentially. And we see very, very high, some here very, very high levels. So what are the levels here in Pembroke? Well, if you look at the third slide from the right, you can see the range from about 7 up to over 200. And this gives you, this range here is indicative of, well, it's not very good data because that is the only data that we've got and has been provided for by CNSC or SRBT. But they're enough to raise alarm bells in my mind. You see, what would be a background level? And the background level would be, say, for Lake Superior, about 3 becquerels per liter. And Lake Superior is chosen because A, we've got data for it, and B, because it's not near any nuclear or tritium releasing facility. So we can use 2, 3 as being a sort of a background level. In other words, tritium does occur naturally in the environment from a number of sources. In addition, if we also go on here to look at sewage sludge from a recent document published by CNSC, we can see that levels of tritiated water of 34 becquerels per kilogram, but more interesting and more alarming in many ways, 400 becquerels of organically bound tritium. That means to me that the concentrations of organically bound tritium in people are higher than this. To produce, how shall I delicately put it, fecal output in the citizens of Pembroke, to have such high levels of organically bound tritium means there are things going on here which we really don't know about. It means that the people are either eating organically bound tritium, because these are very high levels, 400, or they are making it themselves, because we all make organically bound tritium. In other words, the lipids, carbohydrates, and proteins in our body actually use hydrogen from tritiated water to make organically bound tritium. And new cells, which are laid down, also create organically bound tritium. Alarm bells went off when I saw that figure of 400. It's only one figure. Yes, it's true, but it's, there was a previous figure in the year before of 290. In other words, it's not going down, it's going up, if anything. I'd like to see a lot more organically bound tritium determinations made in people near Pembroke. You can do so with non-invasive bioassays, with using fingernails or using hair clippings. It's true that OBT determinations are expensive and time-consuming. However, I think they should be done. Going on to the next slide. People in Pembroke take in tritium by a variety of methods, by eating foods contaminated with tritium, by inhaling tritiated gas or tritiated water vapor, or by drinking tritium-contaminated water, or by skin absorption. In fact, it turns out that inhaling tritium and skin absorption are the 2 main methods of getting tritium in people who live in Pembroke. I've made an estimation based on the methodology of Richard Osborne of the annual intake values of tritium near SRBT, in other words, within a couple of kilometers. As you can see, the air inhalation and skin absorption are by far the largest contributors, but there is a little bit from food and water and drinks. And I came up with a total of, roughly speaking, 2 megabecquerels or 200,000 becquerels per annum. And this is I don't claim a great deal of accuracy for this. I'm using annual intake values from Health Canada, and I'm using the environmental tritium concentrations from the only data that I've got, which has been provided by CNSC and SRBT. But I think that it's the best estimate that I can make. I would say that it's roughly accurate, at least to one significant figure, and I think that that is probably going to be occurring as an average across the whole of the 20,000 residents in Pembroke. So just turning to tritium for a second, the problem is that tritium has very low doses per becquerel. It's one of the lowest of all radionuclides. And the estimated tritium doses by the various official sources are very low, but if there's any error because of the huge tritium releases, then the consequences could be severe. I'm going to have to go on to there's many official reports showing concern about tritium. And what's wrong? Basically, the wrong radiation weighting factor, wrong metabolic models are used, and a refusal to acknowledge its tritium. My main conclusions are that tritium concentrations in moisture, food, water near SRB are high. That we've got high tritium exposures to nearby residents, which are likely to cause raised levels of cancers and leukemias, but they're hard to pick up. And I make a number of recommendations, which you can read for yourself. Sorry, I'm over the time.
Okay, thank you.